Okay, I think the idea of organizing the GSS, Geoinformation Science Symposium, started in 2009. At the time, I was the chairman of PUSPIX, and PUSPIX stands for the Center for Remote Sensing Education and Training of the Gadjah Mada University. And I saw that in between 1990 up to 2000, there was only 3 times seminars on remote sensing. That's why I thought that we need to organize that kind of symposium to attract more people having research in remote sensing and also GIS and cartography. And I also thought that it must be carried out regularly, at least every 2 years or biannually. So that's why we started in 2009 and then 2011 and then 2013, 2015. And fortunately in 2016, the MAPIN is the Indonesian Society for Remote Sensing, asked us, PUSPIX, to and the MAPIN Commissariat of Yogyakarta to organize symposium at national level, but involving people from around the world. And this symposium is called ICOIRS. ICOIRS stands for the International Conference of the Indonesian Remote Sensing Society. It was held in 2016 and it was very successful. That's why after that we thought that we need to change the Geoinformation Science Symposium, which was carried out regularly in Bahasa Indonesia, to more international conference. That's why started in 2017 we changed the GSS into international conference. And in this occasion we already held this symposium for the 4th times. And the motivation behind this symposium is first, of course, we need to publish papers, quality papers from the participants, not only from the lecturers and also students at the Faculty of Geography, but also Gadjah Mada University, and also from people working on remote sensing, GIS and cartography from various institutions in Indonesia and also neighboring countries. I think that's all. Well, I hope that this GIS can be a routine agenda and can develop further to attract more people from around the world involving experts in remote sensing, GIS and cartography, so that this symposium can be an important link of this series of seminars, series of conference on remote sensing and geoinformation science events of the world. And for the 3rd time, we already made contact with SPIE, and we regularly publish the proceedings of this symposium through the SPIE.
Assalamualaikum warahmatullahi wabarakatuh.
Salam, Om Swastiastu, Namo Buddhaya, Salam Kebajikan.
Good morning, ladies and gentlemen. Welcome to the
8th Geoinformation Science Symposium 2023 with the theme Geoinformation Science for a Sustainable Planet. The symposium was organized by Geographic Information Science Department, Faculty of Geography, Universitas Gadjah Mada, in cooperation with Indonesian Geography Association, and will be held for 3 days from 28th until 30th of August 2023.
GSS has a long history, started as a national conference that marked as the pioneer for conference in cartography, remote sensing, and GIS in Indonesia. And now we evolve into international symposium which gather people around the world to share their knowledge, findings in geoinformation science and education.
I am Maskita Abdillah Rafiki.
I'm Afra Abida El Rafi.
We're grateful and delighted to be the master ceremony of this event.
Before we start the event, we would like to remind all online participants to turn on your cameras and turn off your microphones.
Next, we'd like to welcome our special guests and give them our most considerable appreciation for the support of this event. This event is supported by Marine Technology Cooperation Research Center and Directorate of Research, Universitas Gadjah Mada.
Welcome to the Honorable Rector of Universitas Gadjah Mada, Her Excellency Professor Dr. Ova Emilia, M.Med. at SPOGK PhD.
The Vice Head of Indonesian Geography Association, Professor Dr. Muhammad Baikuni, M.A.
Dean of the Faculty of Geography Universitas Gadjah Mada, Dr. Danang Sri Hatmoko, SSI MSc.
Head of the 60th Tis Natalis Faculty of Geography, Universitas Gadjah Mada, Dr. Taufik Heri Purwanto, MSc.
Chairman of the GSS 2023, Professor Dr. Pramaditya Wicaksono, SSI MSc. Keynote speakers, Professor Dr. Menno Jan Krak from University of Twente,
Associate Prof. Chris Rolsema from the University of Queensland,
Professor Dr. Muhammad Kamal from Universitas Gadjah Mada,
Dr. Ariel C. Banko from Philippine Space Agency,
Dr. Yuichi Sakai from Utsunomiya University, Japan,
and Dr. Hansan Park from MDCRC,
and also several respected lecturers from the Faculty of Geography.
Our next agenda will be singing Indonesian national anthem. Ladies and gentlemen, please stand up for the national anthem of the Republic of Indonesia, Indonesia Raya. Ladies and gentlemen, you may sit down.
To express our gratitude and greeting to all guests and participants, we would like to present you a traditional dance performance.
We will be entertained by a wonderful performance only for the 8th GSS 2023. Afra, can you figure out who it is?
Yes, Unit Kesenian Jawa Gaya Surakarta will perform Gambyong Pangkur dance, which shows the attitude and character of Javanese women. Initially, this dance functioned only in harvest stage, but it turned into dance from welcoming the guest. Gambyong Pangkur dance is the variation of Gambyong Pare Anom.
Ladies and gentlemen, please welcome Unit Kesenian Jawa Gaya Surakarta.
incredible performance from Unit Kesenian Jawa Gaya Surakarta. Let's make a round of applause.
Ladies and gentlemen, there will be a remark delivered by Rector of Universitas Gadjah Mada. We would like to invite to the stage the Honorable Professor Dr. Ova Emilia, M.Med. at SPOGK, PhD. Her speech will officially open this event. Professor Dr. Ova Emilia, the floor is yours.
Good morning, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Her Excellency, Ibu Rektor Universitas Gadjah Mada, Professor Ova Emilia, who will open very soon in this conference, and also the Vice Chairman of Indonesian Geography Association, Professor Muhammad Dimyati, all the keynote speakers from the Twente University, from the Philippines, from the UGM, and also from the Queensland University, from Utsumia University, and also from the MTCRC Indonesia-Korea collaboration. And also, of course, respected Chairman, Professor Pramaditya Wicaksono, the organizing committee, distinguished guests, participants, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh, and very good morning. I am very honored to welcome you all on the 8th Geoinformation Science Symposium 2023 in this Faculty of Geography UGM. We are also very grateful to host this prestigious event to discuss and share the future direction of our planet using the geospatial data, information, and also technology. This symposium serves as the melting pot of ideas where the diverse perspective converge to unravel the complexity of our environmental challenges through the lens of the geospatial data and technology. The geoinformation science equips with the powerful tool to navigate, to understand, and to analyze, and to improve our world. In the Faculty of Geography, our vision of sustainable planet has been enriched by analysis and visualization using the remote sensing data and the geographic information system. In addition to that, aligned with the spirit of the 60th anniversary of Faculty of Geography UGM this year in 2023, we are also actively integrating the use of the artificial intelligence in the geographical analysis. This not only digitalize of the analysis, but also revealing the hidden pattern lies in our geospatial big data. The hidden patterns that are very useful to plan and also to mitigate the spatial problem in our world. Our commitment to sustainable planet align perfectly with the university vision for the Sustainable Development Goals. We express our gratitude and thanks to Ibu Rektor for continued support in facilitating our effort to make the meaningful contribution to the society in this regard. Over the next 3 days, I am excited to learn from geoinformation science research. Let's exchange ideas, expand our network, and collaborate to address the complex environmental challenges, including the pollution and the climate change that threaten our planet. Let us learn each other and work hand in hand, which surely will inspire to innovate this field of study where the geospatial data and technology takes center stage in the goal of a sustainable planet. And we also would like also to invite Ibu Rektor then to open this symposium. Thank you very much for your kind attention. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Pak Dekan Danan, because we are the team, yeah, in governing the faculty and also the university. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Distinguished guests, respected keynote speakers from various countries, presenters, and also participants, with warm regards, I welcome you all to the 8th Geoinformation Science Symposium 2023. I think this is one of the lasting conference being held in the Faculty of Geography, Universitas Gadjah Mada, with the value our continuing effort in making the world sustainable. Ladies and gentlemen, in the 8th rendition of this symposium, we are privileged to see the brightest mind and ideas gathered in one place to discuss the advancement of geoinformation science, which serves as a catalyst for accelerating our collective pursuit of the global sustainable development goals. That's already mentioned by the Dean, that the goal of the symposium, which targets sustainable development through the means of geospatial data and analysis, is very much aligned with the mission of Universitas Gadjah Mada at this moment. The commitment of Universitas Gadjah Mada for the environment has been translated in the research strategy, which covered the fields of food security, the climate change mitigation, and also adaptation, which is surely not an easy task. However, we will surely prevail to complete this task with the academic spirits and intellectual minds from each and every one of you. Therefore, here I announce the opening of the 8th Symposium 2023 Geoinformation Science for a Sustainable Planet. I hope you can have an insightful and engaging event in Universitas Gadjah Mada for a better and sustainable planet, of course. Thank you very much and have a fruitful conference.
Thank you for Director Professor Dr. Ova Emilia Ahmed at SPOGK PhD for your welcoming speech. We hope that all participants will get motivated and bring success to this symposium. We also invite Dr. Danang Srihatmoko SSI MSc, Profesor Dr. Pramaditya Wicaksono MSc, dan Profesor Dr. Muhammad Baikuni MSc, and also Professor Dr. Ova Emilia Ahmed at SPOGK PhD to attend this opening symbolic. Thank you. We will.
Thank you for Professor Dr. Ova Emilia, M.Med at SP OGK, PhD, Dr. Dadang Sri Hartmoko, SSI, MSc, Professor Dr. Muhammad Baikuni, MA, and Professor Dr. Pramaditya Wicaksono, SSI, MSc, for attending the symbolic opening of GSS 2023.
We hope that all participants will get motivated and bring success to this symposium.
And we would like to remind all the NTNU delegates to go to the second floor. Next, there will be a report from the chairman of the GSS 2023.
We would like to invite to the stage the Honorable Professor Dr. Pramaditya Wicaksono, MSc. Professor Dr. Pramaditya Wicaksono, the floor is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. The Honorable Rector of Universitas Gadjah Mada that just left us just now, and the Honorable Dean of Faculty of Geography, Universitas Gadjah Mada, the Honorable Representative of Indonesian Geographer Association, and the Honorable Prof. Proyodanudaro as the founding fathers of this Geoinformation Science Symposium, distinguished keynote speakers, guests, esteemed colleagues, participants, and honored speaker. Good morning. It is with great pleasure and excitement that I welcome you all to the 8th Geoinformation Science Symposium 2023, hosted by the Faculty of Geography, Universitas Gadjah Mada in this beautiful city of Yogyakarta. This biennial event has brought together an impressive array of participants from across the globe, representing Indonesia, the Netherlands, the Philippines, India, Sweden, Japan, Taiwan, and also South Korea. Your presence here truly exemplifies the international spirit of collaboration and knowledge exchange that drives the field of geoinformation science forward. With a total of 122 abstract submissions, we have witnessed an overwhelming response from the global geoinformation community, demonstrating the significance and relevance of this symposium. After a careful review process, we are proud to have accepted around 85 full papers that span a wide spectrum of topics within geoinformation science. The depth to our discussion, as we reflect on the journey of geographical knowledge and geospatial advancement over the years. In our continued commitment to adapt and embrace the evolving landscape of global events, the symposium is being held in a hybrid format. This means that while some of us are fortunate enough to be gathered here in person, others are joining us virtually from various corners of the world. This hybrid approach reflects our dedication to inclusivity, allowing the exchange of ideas and insight to transcend geographical boundaries. Moreover, in an effort to nurture the next generation of geoinformation enthusiasts, we are delighted to announce an inspiring side event, a GIS competition and a map competition for university students. This engaging initiative, scheduled for tomorrow and the day after tomorrow on August 29th and 30th provides a platform for young minds to showcase their creative and analytical skills and adding a vibrant dimension to our symposium. For your information, the poster display of the map competition finalists will decorate the north part of our plenary hall. This placement is strategically chosen so that all symposium participants can not only appreciate this effort from our colleagues in the university, but also provide an assessment. This interactive assessment component is integral criterion of the competition. As we embark on this journey of exploration and collaboration, let us remember that the foundation of geoinformation science rests upon the amalgamation of diverse perspectives, experiences, and also expertise. Let the symposium serve as a catalyst for the exchange of ideas, a breeding ground for interdisciplinary partnerships, and a platform for igniting new insight. I extend my heartfelt gratitude to each and every one of you, committees, participants, speakers, sponsors, and organizers for contributing to the success of this event. Let us make the most of this opportunity to learn, share, and shape the future of geoinformation science together. Thank you and enjoy the symposium.
Thank you, Professor Dr. Pramaditya Wicaksono, MSc, for the report.
Next, we have a remark from our honored guest. We like to invite the vice head of the Indonesian Geography Association.
Please welcome Professor Dr. Muhammad Baikuni ML to deliver his speech.
Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for inviting me here. His Excellencies, Rektor Universitas Gadjah Mada, His Excellencies, the Dean of Faculty of Geography, Professor Menno Chandkrak, the President of International Cartographic Association from the Netherlands, and also Dr. Ariel C. Blanco from the Philippines, Space Information Infrastructure Bureau, the speakers, also participants, and all the organizers and sponsors. On behalf of Indonesian Geographical Society, Professor Muhammad Dimyati asked me as a Vice President to deliver the speak here, and we are happy to congratulate the 8th Geoinformation Science Symposium. It is very important that this symposium provide discussion and sharing information among lecturer, the researchers, the student, and also the professional. With the topic of geoinformation science for a sustainable planet, we see that the important element of geoinformation for supporting the sustainability effort. And we have great effort for partnership and collaboration to create big solution for the future. We have sustainable development goals up to 2030, and we have to work hard and hand in hand for solving the many and various problems, from the poverty alleviation, the hunger, up to the partnership of the goals. And with the 17 goals, we need geoinformation as the core of the providing the information and related to the quality of data, quality of information to have a good decision making, as well as the program planning and also the continual implementation. Geoinformation system is also very important for monitoring and evaluation of the progress, we need to reflect what have been achieved since last decade. And we have to also have some kind of the future vision to solve the problem. Ladies and gentlemen, we also congratulate the Faculty of Geography, the Dies Natalis of the 60. We give applause for this event. And we are also happy that we have 3 new professors, Professor Projo Danudoro, Professor Prama, and also Professor Kamal. Big applause to them. This to show that we have already 16-year biannual symposium meeting now, and Professor Proyo, since his leadership at that time, and now the 3 of this new professor will provide a strong department for the future. It is as Indonesian Geographical Society, we appreciate all the effort, and hopefully we are going to inspiring others. I inform you for international conference in Aceh next 22 and 23 November, and in conjunction with 25 annual scientific forum of the IGI, or Indonesian Geographical Society. And we hope also you can participate both online or also luring in Aceh. So welcome to have next meeting in Aceh. But here, start from here, we can share many things important about the Geoinformation Science Symposium. Once again, congratulations for this event. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Dr. Muhammad Baikuni, MF, for the welcoming remark. Ladies and gentlemen, we have reached the end of the opening ceremony of the 8th Geoinformation Science Symposium 2023.
On behalf of the host and committee, we would like to appreciate all attendees for your participation and support.
And we would like to apologize if there are any mistakes that we made in this opening ceremony. Thank you for attending this opening ceremony.
Ladies and gentlemen, you are welcome to take a coffee break on the left side of this auditorium Merapi. Then we will be back in 10 minutes for the plenary session. Thank you.
Okay, I think the idea of organizing the GSS, Geoinformation Science Symposium, started in 2009. At the time, I was the chairman of PUSPIX, and PUSPIX stands for the Center for Remote Sensing Education and Training of the Gadjah Mada University. And I saw that in between 1990 up to 2000, there was only 3 times seminars on remote sensing. That's why I thought that we need to organize that kind of symposium to attract more people having research in remote sensing and also GIS and cartography. And I also thought that it must be carried out regularly, at least every 2 years or biannually. So that's why we started in 2009 and then 2011 and then 2013, 2015. And fortunately in 2016, the MAPIN is the Indonesian Society for Remote Sensing, asked us, PUSPIX, to and the MAPIN Commissariat of Yogyakarta to organize symposium at national level, but involving people from around the world. And this symposium is called ICOIRS. ICOIRS stands for the International Conference of the Indonesian Remote Sensing Society. It was held in 2016 and it was very successful. That's why after that we thought that we need to change the Geoinformation Science Symposium, which was carried out regularly in Bahasa Indonesia, to more international conference. That's why started in 2017 we changed the GSS into international conference. And in this occasion, we already had this symposium for the 4th times. Yeah. And the motivation behind this symposium is first, of course, we need to publish papers, quality papers from the participants, not only from the lecturers and also students at the Faculty of Geography, but also Gadjah Mada University, and also from people working on remote sensing, GIS and cartography from various institutions in Indonesia and also neighboring countries. I think that's all. Well, I hope that this GIS can be a routine agenda and can develop further to attract more people from around the world involving experts in remote sensing, GIS and cartography, so that this symposium can be an important link of this series of seminars, series of conference on remote sensing and geoinformation science events of the world. And for the 3rd time, we already made contact with SPIE, and we regularly publish the proceedings of this symposium through the SPIE. When we talk about sustainable planet, we cannot separate it from the geography as a discipline, because as we know, geography has a major concern with the sustainability. So geography can view the world by using spatial, ecological, and also regional complex approaches. That's why by using remote sensing and also GIS and even cartography, we can try to, to reduce the appearance of the Earth's surface in such a way so that the appearance can be made easier to observe. So by using the geoinformation science as a spatial analytical tools, we can make a better contribution of geography to to overcome problems for the more sustainable planet. Well, I remember that when the computer vision and image processing technologies were still rare in 1970s, remote sensing already started using this technology for analyzing images obtained from the space satellite, for example. That's why we can say that remote sensing is one of the leader in this field, even though actually it is supported by technology and computer vision. And we can look back to the year of the middle of 1980s, when expert system is not fully understood by many people. Geographic information system already adopted this technology to solve many problems related to the natural resource management, how to overlay many maps controlled by the knowledge formalized into computer-based rules in such a way so that a good decision support system can be made for land evaluation, for spatial planning, and even for predicting the future land cover and land use. And now we can see that many people talk about artificial intelligence, and actually GIS already made this improvement of this technology in 1990s. So that's why I'm sure that GIS can play an important role in the future for developing and using artificial intelligence for solving many problems in the world, particularly the ones related to the spatial problem. Okay, I think the idea of organizing the GSS, Geoinformation Science Symposium, started in 2009. At the time, I was the chairman of PUSPIX, and PUSPIX stands for the Center for Remote Sensing Education and Training of the Gadjah Mada University. And I saw that in between 1990 up to 2000, there was only 3 times seminars on remote sensing. That's why I thought that we need to organize that kind of symposium to attract more people having research in remote sensing and also GIS and cartography. And I also thought that it must be carried out regularly, at least every 2 years or biannually. So that's why we started in 2009 and then 2011 and then 2013, 2015. And fortunately in 2016, the MAPIN is the Indonesian Society for Remote Sensing, asked us, PUSPIX and the MAPIN Commissariat of Yogyakarta to organize a symposium at national level, but involving people from around the world. And this symposium is called ICOIRS. ICOIRS stands for the International Conference of the Indonesian Remote Sensing Society. It was held in 2016, and it was very successful. That's why after that we thought that we need to change the Geoinformation Science Symposium, which was carried out regularly in Bahasa Indonesia, to more international conference. That's why started in 2017 we changed the GSS into international conference. And in this occasion, we already held this symposium for the fourth times. Yeah. And the motivation behind this symposium is first, of course, we need to publish papers, quality papers from the participants, not only from the lecturers and also students at the Faculty of Geography, but also Gadjah Mada University, and also from people working on remote sensing, GIS, and cartography from various institutions in Indonesia and also neighboring countries.
of Queensland, Professor Dr. Muhammad Kamal from Universitas Gadjah Mada, and Dr. Hansan Park from Marine Technology Cooperation Research Center.
Therefore, we would like to welcome Professor Proyo Danudoro MSc PhD as the moderator for this session. Professor Proyo Danudoro, time and place is yours.
Good morning, ladies and gentlemen. In this session, we have three speakers. The first one is Associate Professor Chris Rosma from the University of Queensland, Australia. And the second one is Professor Muhammad Kamal from the Faculty of Geography, Universitas Gadjah Mada. And the third one is Dr. Hansan Park from Korea. Because Associate Professor Chris Rosma and Dr. Hansan Park are talking online, so I would like to invite Professor Muhammad Kamal to sit here to accompany me. Please welcome Professor Muhammad Kamal. Yeah. Oh, I'm here. Okay. And for the first speaker, Professor Chris Rosma, I would like to read his CV. Yeah. The education background is Nautical School, Amsterdam, and he obtained his bachelor's degree in hydrographic engineering from 1985 up to 1989. And then he continued his study at the Delft University of Technology, and he obtained his Master of Geodetic Engineering, Remote Sensing and GIS in 1989 up to 1993. And if I'm not mistaken, he was supervised by Professor Menno Jan Kra. Yeah. And then he continued his study at the University of Queensland, Australia for postgraduate diploma in marine science from 1998 up to 1999. So you can imagine he moved from geodetic engineering to marine biology. Yeah. Then he obtained his PhD in coral reef remote sensing from the University of Queensland from 2004 up to 2009. Yeah. And his experience in the University of Queensland, now he is Associate Professor in Remote Sensing Research Center, University of Queensland, started from January 2022. And before that, he was Senior Research Fellow Coastal and Marine Remote Sensing at the University of Queensland from January 2018 up to December 2021. And prior to that position, he was the Research Fellow Coastal and Marine Remote Sensing at the University of Queensland from July 2016 up to January 2017. Yeah. And also University of Queensland as a lecturer researcher from July 2010 up to January 2016. And as a research fellow from January 2007 up to June 2010. And research assistant from June 1999 up to January 2007. And the project is the Estuarine and Marine Classification Workshop, revising the NISP or GBR MPA representative from May 2013 up to present. Yeah. And for the second and third speakers, I will be reading their CVs later after Professor Chris Rosma making a presentation. Good morning, Professor Chris Rosma. Goedemorgen.
Goedemorgen. Good morning. Selamat pagi.
Ja, alles goed?
Alles goed.
Ja,
Terima
okay.
kasih banyak.
Thank you very much. Yeah. Now, time is yours, and you have 40 minutes for making your presentation. Okay, please.
Okay. Thanks everybody for this welcome, and thanks for inviting me to provide a keynote address. And also that I'm the first one, which is an honor. And to be honest, like like Projo said, Pak Projo said, Menno Jan Kraak in the audience is very special for me as well as being one of my supervisors in my career. So before I get started, I'd like to show my respect and acknowledge the traditional owners of the country, the sea country I've been mapping over time in space, and I have visiting in that time. My talk will go about, for some people, obvious coral reef and seagrass habitat mapping from sites to local to global scales. And this is not only work for myself, but I have a whole team of people that I slowly during my talk will introduce. But before that, as some of you know, I'm an Orang Belanda, and I started diving in 1981 and dove in lakes with 2 meters visibilities and 4 fish if I was lucky. After 500 dives, I realized that I had to get to some tropical water. In that time, I also did my degree at the University of Delft in geodetic engineering and was fortunate to go to glaciers in Greenland to look at change over time. Currently, I'm not able to be with you because I'm on a field trip here on the Heron Island Research Station, which is part of the University of Queensland. It's a research station. It's about 70 kilometers offshore of the mainland, and it's one of the 3,000 reefs on the Great Barrier Reef, where the University of Queensland has a research station from where we have done a lot of work, and which I would say is the basis of a lot of the research and the success we had with remote sensing. On the right, you see here the research station. And yes, because I'm there, I was not able to join. But I directly want to go into my experience with working with OGM and a long time experience. I met Pak Projo at University of Queensland when he was doing his PhD. Then I met Kamal as well when he does his PhD. And then I met several of their students, including Pak Prama on the various workshops that Professor Stuart Finn and myself attended in UGM and also in Karamanjawa, and learned a lot from the technique and the knowledge gained by the Indonesian colleagues. And this resulted also in many collaborations. And I will finish with one of the main collaborations in my talk. The Remote Sensing Research Center is set up by Professor Stuart Finn and myself about in 1998 to 99. And it's a center that is focused on terrestrial, marine, atmospheric and marine remote sensing. And where I basically lead with my team the marine remote sensing. And in that area, we have done lots of work in different directions, focusing on mapping, monitoring, modeling, and all creating applied tools to work with the environment and support management of these beautiful environments we work in. And as I mentioned, I did it not on my own, and you can see here lots of people on this that have contributed to this work. You see that there's an expertise in coral reef and seagrass ecology, and in remote sensing, GIS, Google Earth Engine, object-based image analysis, coding, statistics, etc., etc. And that's supported not only by the staff, but also by the series of PhD students and master students that are working with us on various projects where remote sensing is used, making it a very exciting project. The projects we're working on are varying throughout the world, I have to say, which focus on Heron Island and the Eastern Banks. Many of you maybe have seen our papers on coral reef and seagrass mapping as well. Those form the basis where we did annual surveys, and that resulted in our knowledge and skills to look at larger scale areas. And currently we're working on projects in Great Barrier Reef, Northwest Australia, as well. there's something going wrong with the sound. Oh, that's going good. Okay, do you hear me well? Hello? Can you hear me?
It's all good, Chris.
Oh, good. I got an echo. Okay, so I'll continue. So, where is it? Oops, there. Yeah. Okay. So we're covering large areas in the world. In my talk, I will talk about coral reefs and Earth observation in January, some introduction. Then I will go into some of the developments where we're working on, and then I'll go to some of our global efforts and summarize it then. So if you look at coral reefs and mangroves and seagrass systems globally, you can just see this slide which originally created by Dodi Yomono as part of his PhD, where you can see the connection between those three environments. And what you can also see is that Indonesia and Australia have a major impact on the diversity and the distribution of those systems in the world. They are in the center of those areas. And it's therefore also a delight to work in these regions and be able to visit them and also share knowledge with the different organizations in those countries. Why are these so important? Well, if you reckon that coral reef and seagrass habitats cover almost 1% of the Earth's surface, which is a relatively small area of the world's oceans, I should say. But 25% of all marine species are actually depending on these environments. And over 500 million people are depending on the health of these reefs and the food resources, but also coastal protection and also building materials. So there's a lot of dependence of these systems. Blue carbon source, it's enormous blue carbon source, especially for seagrass and mangroves. Most of these habitats are insufficient mapped, and as a result, it's hard to manage them. Now, a lot of this information you can actually find also in a book that was created at the University of Queensland and was translated with marine fisheries about coral reefs as well, and you can have a look at it as well. On understanding these habitats, it needs to know how the light, the temperature, the depth, the hard bottom, the waves, how they grow, how they impact how algae, rock, rubble, sand, seagrass, and corals grow. We call this the benthic environment. And understanding that helps us with mapping it. It's not only if you look at a satellite image that it's hiding these kind of features, but it's also hiding the geomorphic zones. Once you know the geomorphic zones, so like the reef slope or the reef crest, then you can also get a better idea where you should go fishing or diving in the world, or which areas are of importance. So knowing these areas helps managers better and scientists better understand how to protect them. It's like if you have a supermarket and you have an accountant of the supermarket. If the accountant knows very well what's the size of the supermarket and number of shelves, but also the number of products, it can better estimate where attention should be taken to take care that the supermarket stays going. So to do that, one of the things to create this habitat is that we need as produce to get agreement about a habitat scheme. And a habitat scheme that decide on the classes that you want to map. Here I show it for the marine environment, but that's for any environment. Till recently, that was mostly dependent on the color of the pixel and textures as being the main things that help describe those habitats. But we now are able to use other physical attributes to extract from these environments as well and use as indicator to split those different categories apart, like depth, slope, waves, and consolidation. But also our spatial relationships can be used, like neighboring or enclosing or shape. All these kind of attributes can be used to differentiate between those different categories. The same way when we look at a map of a coastline, if we see mangroves in the middle of a country, then we know, well, that's not completely right because they should be neighboring the ocean. So understanding these environments and using remote sensing for these environments requires of an understanding of what happens with the light when it progresses through the atmosphere, is then reflected from the surface and comes back. For land, this is where it stops. This is what you see. But when you go to the marine environment, you get challenges with scattering of light and absorption by the composition of the water column with inorganic and organic matter that basically changes how light is influencing what you actually can see in satellite imagery. And on top of that, you have the movement of the water column, tidal movement, waves by wind and currents. And anybody who's been out to the water knows that if you go on a boat and you go around with the boat, if you can't see the bottom, then don't expect that you can see it from space. It's really dependent on how deep and how clear the water is. And of course, when there's clouds, and especially in equatorial countries, that is a challenge, then it's harder to map these environments. Now, many of the knowledge we gained over time, we shared online with courses that people can sit, and you can see the remote sensing course that's organized by the Nature Conservancy, but also the remote sensing toolkit, which is with the help of the students of UGM translated to Bahasa Indonesia as well. And anybody can use those toolkits, and which help them also to get a better understanding of how remote sensing works, not only in the marine environment, but also in the terrestrial and atmospheric environment. So having this basis, I now go some of the developments of marine Earth observations that are happening. With our habitat mapping framework where we're working on, it's important that we start to consider our mapping approach, that we keep in mind that it's repeatable, so that it's comparable, that it's semi-automated, because we don't want to keep on manually drawing lines, but we want to automate it as possible. For us, it's very important that it's also publicly accessible. So the products that we create, that we can share them with the people who can use them. And that we use consistent image data sources, but also integrate them with local knowledge. But we can keep in mind that it not always works. So in some cases, you have a constraint in the mapping approaches, like we can only work in clear, shallow water, which basically means at the global scale that is roughly about 10 meters deep. But in French Polynesia, for instance, in the Pacific, it could be up to 40 meters deep. It really depends on where you are in the world. You have limited class differentiation. So to a certain extent, we can defer the different components that we are interested in. But yeah, we are limited to that. And when we choosing mapping approaches, they could be consistent at a global scale, but less consistent at a local scale. So this work that was initially started on Heron Reef, where I'm currently are, where we have an ongoing monitoring program. And then it went throughout different areas in the world, in the Caribbean and in the Pacific. That resulted that we got projects going for the whole Great Barrier Reef, where we mapped every single reef using a combination of different methods. These methods are usually driven by a classification scheme, our ecological local knowledge of the field. And as some of you will know, one of my comments is always that students, if they learn to map something, or anybody, they should go in the field to understand that in environment, to basically get an idea of what is there and what's not there. So you need local knowledge. You need Earth observation and field data, and that was the most traditional way how things were mapped. But in our approaches, we now also include biophysical attributes like depth, waves, and slope, as I mentioned before. And we're looking at using water clarity and temperature as potential indicators. For our input data, we use close-range Earth observation. So photographs taken by a diver, snorkeler, or a robot that swims over the surface while towing a GPS at the surface that records the position, because a GPS signal doesn't penetrate underwater. These photos can now be analyzed using machine learning, and Reef Cloud is a program set up by the Australian Institute of Marine Science. And that program itself helps analyze for us thousands of photos. And it's not only the two-dimensional photos, but it's also three-dimensional. And although some in the marine science community thinks that photogrammetry is something discovered in there, as we all know, that is coming way back where airplanes basically combined overlapping photographs to get orthomosaics. But this is now repeated at a really close range on coral reefs, where divers are swimming with two cameras on a bar and lawn mowing an area to get information out of that area using the orthomosaic, and getting not only the composition, but also looking at the structural complexity and looking at changes over times. And it's a groundbreaking work what's happening there for marine science, although it's something which is some of you are very well aware of at large scale. Drones, of course, are closing the gap between satellite field data and satellites, and provide a wealth of knowledge of high resolution information. Although it's very valuable, it only covers a relatively small area of large reef systems, but definitely following up. So that's where we have this combination of instruments that have different platforms, different pixel sizes, different extent, different revisit time, different sensor time. And here are the systems that are collected in the water. Now, from space, we now have the access since 2015, roughly, from planet data and sentinel data, which provide us almost the daily coverage of the world's surface. And it's just mind-blowing that, of course, we should not forget the Landsat image archives that goes way further back. But the difference in spectral characteristics and spatial characteristics helps us better to map features on the Earth's surface. The now increased development of hyperspectral sensors will provide the ability to have more chance to differentiate between, for instance, live and dead coral, which is still something which is so much wanted for marine scientists, but hard to get from Earth observation at a large scale. Our methods using Google Earth Engine approaches, where we develop scripts that basically take care that the data is ingested and then segmented. Then we apply a random forest classifier that basically labels all the different categories based on the input data, like the imagery, the depth, the slope, the waves. And then a first random map, a raw map comes out. Then we use object-based image analysis, or I should say object-based analysis, because we analyze the results of the raw data, raw classification, using our neighborhood rules or physical attributes to improve the maps that we created, to create these geomorphic and benthic maps. And of course, then we do an accuracy assessment as well, and quality control. So as an example, here on Heron, we have been collecting satellite imagery for the and photographs for the last 20 years, and it's probably the highest density field data for georeference field data for habitat mapping on an annual basis. We collected over 3,000 photos. In the beginning, it would take us 3 to 4 weeks to analyze these photos, and now basically in 2 days' time they are spit out of the machine learning component, which provide us so much knowledge at the site scale of the different areas. These little graphs present the different sites where every line is basically a coral type and a time in space as well, over 20 years. So that's a wealth of information that we now can start using. Additionally, from previously, we hoped that we would have one good satellite image for which we could map, for instance, seagrass in the Moreton Bay. Now we are able to look at stacks of imagery and select the best images that are cloud-free, that are high quality, that have less sun glint, less good clear water. So we are able to get way more information than in the past, resulting in better maps as well. The other thing we do now, this is an example in Tonga, where there was a tsunami in 2022 as a result of an eruption of a volcano. And that basically hit the island state of Tonga very well. That was in 2020. So as a result, we could use the Planet Archive to look at imagery the day before the tsunami and the days after. And together with the local knowledge of the fishermen, the community, we are now creating maps of change in the habitat to assess how much of the habitat is impacting and where restoration should take place. Similarly, combining all these different data sets to look at using citizen science, field work, photo portraits, and satellite imagery, and have mapped the whole Great Barrier Reef. Every single reef was mapped at the same way. We visited over 100 reefs where we collected these yellow dive transects or the red snorkel transects. And on each transect, we have collected hundreds of photos. So providing us information that helps management to better understand this. And again, it's a combination of field data, physical attributes, satellite imagery to come to these products. Now, all this knowledge was then used and all these developments are used and gained for global coral reef and seagrass mapping effort. And I'd like to have you look at this little video.
Awalnya karang itu saya kira seperti akibat biasa saja. Terumbu karang itu sebagai sumber oksigen ya, yang produksi oksigen lebih dari pohon. Masa kecil saya waktu itu kerjanya ke laut hanya merusak terumbu karang. Karena tidak tahu apa sepentingnya terumbu karang, hanya asal tangkap ikan dan menginjak-injak terumbu karang. Bagi saya tidak ada perasaan apa-apa waktu itu, enjoy saja. Pertama itu karang, karena begitu saya tanya apa itu karang, saya bilang batu itu loh. Jawabnya keras lagi, udah kenceng, salah gitu loh. 70% ya jenis-jenis karang berada di Indonesia. Posisi Indonesia di antara 2 samudra dan 2 benua, dan itu yang membuat ketahanan terumbu karang di kita ini lebih tahan dibandingkan yang lain. Di Indonesia terumbu karang sangat berarti, sangat memainkan peran penting bagi pemangku kepentingan, baik itu perlindungan juga manfaat ekonomi ya melalui wisata maupun perikanan juga, dan tentunya sangat penting dalam hal estetik dan juga sosial budaya. Kebutuhan data itu menjadi concern kita semua. Tidak hanya kementerian yang mengurusi tentang laut, jadi kita semua terintegrasi. Project Island Color Atlas menjadikan salah satu terobosan yang ada di dunia bagaimana untuk memetakan seluruh terumbu karang Indonesia dengan resolusi yang sangat cukup detail dan di mana mereka menggunakan tools dan alat baik menggunakan teknologi penginderaan jauh atau remote sensing dan di mana ini bisa diakses secara online dan juga data bisa di-download secara gratis.
Island Coral Atlas ini dapat membantu kerjaan saya sebagai seorang coral reef ecologist karena kemampuannya menyediakan data skala besar tentang kondisi kesehatan dan penyebaran terumbu karang. Ini bisa menjadi baseline data untuk perencanaan. Jadi kita sudah memiliki data dasar untuk menentukan langkah-langkah apa yang harus dilakukan pada suatu daerah.
Bagaimana informasi tentang manfaat fungsi dari terumbu karang untuk masa depan anak cucu kita 10, 20, 30 tahun mendatang ini menjadi penting. Sehingga informasi ini mudah-mudahan dapat juga mempengaruhi kebijakan-kebijakan di luar sektor kelautan dan perikanan. Island Coral Atlas akan sangat membantu pemerintah Indonesia dalam mendukung upaya 30 juta kawasan konservasi pada tahun 2030. Dari beberapa workshop yang diberikan kami mengakui dan itu sangat pentingnya karang terhadap kehidupan manusia dan alam.
So here you saw my a video created about the Island Coral Atlas, how it's used in Indonesia, but it's actually used globally in lots of countries. And through the presentation, you saw that it shows different products, mapping products, monitoring products, and it's an integration of various data sets. It's a result through the generous gifts of the late Paul Allen, co-founder of Microsoft, who set up a philanthropic organization called Vulcan, who basically worked with the co-founders, Arizona State University, Planet, University of Queensland, National Geographic, and Coral Reef Alliance to create this tool. Where Planet provided the satellite imagery, the Arizona State University basically prepared the satellite imagery so that it was ready for the next step, but also created depth derived from satellite imagery. Together with teams, we collected the field data, the University of Queensland, and conducted the mapping. The Arizona State University and Coral Reef Alliance created the monitoring protocols, and that all is being spread out and engaged through National Geographic and the Coral Reef Alliance. So you can see it's a large-scale project with lots of different organizations. For the mapping component, where my team was responsible for, we basically divided the world up in 31 different zones or areas. They were not cultural or geographic, they were chosen to be characteristic for the kind of coral reefs in those environments. For each area, we used satellite imagery, and we used over 2 million satellite imagery for making the habitat maps of the world, of the coral reefs of the world. We used planet data mostly for the mapping, where we use sentinel data to derive depth, but also for the monitoring tool. And the monitoring tool is developed by the Arizona State University. To make this happen, we needed to reach out because on the start of the project, COVID happened and we needed to go in the field, but we couldn't. So we basically reached out online to the sources of field data and maps. We reached out over 1,000 different people and got over 500 different data sets that were structured on such a way that we could use them for the next step. Because those data sets were reviewed by my team at the University of Queensland, and we looked at how we could use it to make our maps. And therefore we had to format them for different levels in global categories. We used Earth observation, so we created our pro environments in GIS Online so that we could share the data between the different teams and also assess it. Then we needed to create reference data from these data sets, and we used Ecognition, object-based analysis to create and label segments that will represent our reference data sets. All these combined, you can see that we use different techniques of GIS and remote sensing to come to these products. Then in cloud processing, which I would specifically mention, Mitchell Lyons developed code to basically go through the different components. We had 300 scripts and 300,000 plus code lines. Some of the scripts would run in 10, 20 minutes, where others would take several hours, sometimes several days, depending on the size of the area. So Indonesia was one of the largest areas, and that took several days to get a result out. And so that ongoing feedback mechanism required also that it took sometimes a couple of weeks before we were happy with the maps. And what means happy or pleased with the maps? Well, we basically did a quality control of these maps and did that in several ways. So one way is we published the methods that we created with peer review. So that means somebody reviewed all our papers, and that's what we could, was one step of quality control. Then we had peer-reviewed reference data. So the data we used, we checked and was checked already by others. And then we created, we split it and we did internal reviews and cross-checks with my team as well. And then we did final review where the principal investigator took care that all the maps were signed off. And of course, we did our standard accuracy assessments as well, where we used part of the part of the field data for the calibration as well. And then we had a process in place where we had an external review with feedback process with regional experts that we approached to assess. And several people in the audience or online have been part of that process to collaborate with us to assess how our maps were. And as a result, these maps are now accessible online. Anybody can download them. Anybody can do statistics on them anywhere in the world. It can be used by high school students to learn about coral reefs, but it can use also by managers to basically do an assessment of where to start restoration, as an example, of coral reefs. This combined with the bleaching and turbidity monitoring tool, and also the analysis ability with marine protected areas, provides a very powerful tool for conservation of coral reefs, and provides the ability to save these coral reefs, to at least give it a chance. Now, lots of people were involved. We worked with 14 people from UQ, but we had also people from the co-founding partners that collaborated with us. We had 12 different nationalities, and we worked over 7 different time zones for a period of 2 to 3 years. The people online were, the people working on it had all different backgrounds to make this happen. So it's a really big effort. And you can see on this website, you can scan the QR code of some of the successes, how the maps are being used, inclusive the fact that the maps created for Indonesian are integrated in Ministry of Marine Affairs for management goals within Indonesia. But there's all those other examples where you can have a look how it's working. Now, what's next? Well, next is seagrass. We are asked to write a proposal to map seagrass globally. But seagrass comes also in temperate waters and not only in the tropical waters. And seagrass is also different than coral reefs, where corals maybe grow 1 to 12 centimeters a year. Seagrass can grow really fast, but can also die off quickly on a natural way, the same as the grass in your lawn, to say it's simple. So there's some seagrasses that are always there, they're persistent, and some are colonizing. So it doesn't mean if seagrass is gone, it's not a seagrass habitat, it's maybe just gone for the season. So that gives us extra challenges to map these environments. And that's why we're using a combination of the same methods as we talked previously about to follow this approach and look at the global seagrass map once the funding is due. But luckily, we start to have some luck already. So together with some other organizations, the Pew Trust and the Nature Conservancy, but also at University of Queensland, we have some large-scale programs that mapping large areas already. Together with the Allen Coral Atlas map that includes seagrass as well, we are on our way to start getting good maps of coral reefs. And just recently, with the help of Pak Prama, who is leading an effort to basically with the universities in Indonesia, but also government agencies, to basically get a team of people together that you can see here on our latest online meeting, where with funding from the Lucille Packard Foundation, we start planning to map all the seagrass in Indonesia, which is an enormous effort, and it's a result of a lot of pushing and negotiating between the team that you see here on the photo. So this shows us an example summarizing this on how coral reef and seagrass remote sensing is developing in time at site scale to global scale, and where we're not only looking close by photography, but also with satellite photography, and both are forms of Earth observation, where the people that are involved with the different projects are really important to share their knowledge and to help to create this support for decision making. Our future is focusing on hyperspectral work and mapping of global seagrass. And Indonesia, as you can see in the last slide, as previous slide, is a major player in large-scale mapping effort. Thank you for your attention, and if you have any questions, let me know. I think that I understand your question well. The question was how long the habitat maps would be valid, and if you want to remap it, if you had to start all over again. Now, I understand that you're a student at the university, and I think that there's an important spot for the students there to help improve our mapping efforts, any mapping efforts. So that's first thing. Secondly, I would say that when we developed the different mapping approaches for the coral reefs and also for seagrass, it was for us of importance that it was repeatable. So we purposely choose an approach where we can use or sentinel imagery, or if you have access to planet imagery that is globally covering. Although we wish we would do it with Worldview 3 or something, with really high resolution imagery, or SkySat, the cost to get a whole coverage of, for instance, Indonesia, that is cloud-free, that's very challenging. But going back to your question, it is repeatable. Yes, it is changing. Coral reefs on its own, if there's no impacts, are changing slowly and increasing. But if there's impacts, like for instance coral bleaching, then there's quick changes and they are hard to pick up because it's basically coral and algae looks very similar. Seagrass is different. Seagrass changes is more likely to be picked up from space. I hope that answers your question.
Okay, thank you very much. More question or comments? Yes, please, come forward. Please introduce yourself.
Okay, thank you Pak Proyo, Pak Kamal, and Pak Chris. My name is Wawan from Universitas Brawijaya. As your last slide said that the challenge is about hyperspectral imagery, and as long as I know that there is no more hyperspectral imagery since EO1 stopped acquiring our Earth. What is the solution for this hyperspectral imagery that can freely access to anyone? Thank you.
The challenge is that I think for mapping benthic habitats, you need high resolution spatial. So 5 to 10 meters is really what you like, if not smaller. And hyperspectral you would require to help increase the chance to differentiate between corals and algae, or between different seagrass species. Now, currently there are several efforts on the way to create new hyperspectral sensors. I know Planet is planning a new constellation. I know that NMAP has a sensor, the EMIT, a sensor on the space station, and the CSIRO, the research organization in Australia, is collaborating with NASA and with UQ to create a hyperspectral sensor as well. The challenge is that scientists like myself are pushing the technicians to the limits of getting smaller pixel sizes because many of them are still around 20 to 30 meters. Having said that, I'm pretty comfortable that it's going to happen, and I think Planet is a nice example from who could have imagined that. Who could imagine 5 to 10 years ago that you can now go online, look in an archive, and see a satellite image of your area of interest close by. So yeah, I do think it will happen.
Okay, thank you. Professor Krag, please.
Hello, Chris. Good to see you, and thank you very much for your presentation. It's impressive. Two questions. One is related to your reproducibility and the future. So, and it's not necessarily about satellites getting more detail, but more your whole workflow, which you have somehow presented. Is that future-proof, so to say?
I would say so, because we developed the workflow is based on terrestrial work, what's happening here in Queensland, where they're now able to remap, following that similar kind of workflow, the state of Queensland, which is many times bigger as Holland. They are able to, on a monthly basis, follow that workflow. And the challenge with the marine environment is, of course, the changes in the water composition, surface water, there's wind and waves, etc., etc. But we're pretty comfortable that that workload starts to work, and that's what we're showing with our time series analysis from smaller areas, that it is a repeatable effort.
Okay, and my second question, if I'm allowed, that would be related to the usability of your final product. So have you any feedback from users that your atlas is well designed, so to say?
Yeah, but that's why I would send back to the slide with the impact, where in story maps they created to show where it has been used. And the feedback is sometimes unreal in the sense that we not always realize that it has such an impact. So for my work, I had to go to Tonga, and I walk into the fisheries office, and I see on a screen the island coral atlas map, and I see that the person is basically using them at that moment to make a decision about fieldwork and about where to go. Or another one was that at the University of Queensland, unknowingly, I was invited to a workshop for about 200 students, and I come in that space, and on every screen there was the Allen Coral Atlas. And the students were learning about marine park management and the composition of the reefs. And to make the story interesting or funnier, I come back in my office and I get an email from Arizona State University, where the server is with all the data, with the question, what's happening in Queensland, because so many people are using it. But so we're getting a variety of feedback, and the most common challenge is the fact that the atlas shows coral and algae as one class. And from the start, I knew that that would happen, because I was not willing to say that we would make a live coral map, because you can't with these days. And one last thing, what I can advise anybody, be open and transparent in how you do the mapping, your project, is really helpful to get people understand what these products can and cannot do.
Okay, thank you very much.
You're welcome.
Thank you, Professor Krak, and also Professor Rosma. Is there any more question or comments? Yes, please.
Thank you, Pak Chris. So my name is Jamal. I am from the National Central University. So my question is, if we talk about the global scale approach, so is there any correlation between the climate zone and the benthic habitat? Is your model already consider the climate feature? Thank you.
Now our model is ready to remap areas with new imagery and new field data. I presented in this talk the work on Heron Island, where every year we go back and get field data, and we know that coral reef, the coral buffer under healthy circumstances maybe grows 3% coral a year, and the 3% growth is smaller than the error that satellite remote sensing provides us to pick those differences up. So as a result, it needs to be a couple of years to actually pick up impacts. And so that's still a challenge using Earth observation. And that's also why I would always say Earth observation will, for coral reefs and seagrass environment, will always go together with field data collection and understand local knowledge as well. And it will also go together with biophysical attributes like depth, slope, waves, but also sea surface temperature, because that will help us map these environments. I hope it answers your question.
Okay, thank you very much, and I think time is up for Pak Chris. So please give big applause for Pak Chris for the fruitful. Yeah. Thank you very much, Pak Chris. Now we will move forward to another speaker. Yeah. Thank you very much, and see you next time. Yeah.
Terima kasih banyak. Sampai jumpa lagi.
Dank u wel.
Alsjeblieft.
Okay, now the second speaker is Professor Dr. Muhammad Kamal, and I would like to read his short CV. Where is it? Yeah. Batasi. Okay. Okay, thank you. So the second speaker is Professor Dr. Muhammad Kamal, and the education background, undergraduate in geography, specializing in cartography and remote sensing from August 1997 up to August 2004. And the thesis is the analysis of flood susceptibility by using Landsat ETM plus imagery and case study in Demak, Grobogan regencies. And he obtained his master's degree in Geographical Information Science from the University of Queensland from January 2007 up to July 2008. And the thesis is the airborne hyperspectral data for mangrove species mapping, a comparison of pixel-based and object-based classification. And then he continued for PhD in 2011, February up to September 2015. And the thesis is remote sensing for multi-scale mangrove mapping. Yeah. And he is now the Vice Dean for Education, Teaching, and Student Affairs. And he is also the professor in remote sensing for mangrove or vegetation in general. And for Professor Kamal, the time is limited to 30 minutes for presentation, followed by 15 minutes maximum for a discussion. Time is yours.
Okay, thank you, Pak Proyo. Good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. It is my pleasure to join the 8th Geoinformation Science Symposium 2023 this morning. My name is Kamal. I'm the member of the Remote Sensing Laboratory at the Department of Geographic Information Science at the Faculty of Geography, Gadjah Mada University. And today I'm going to talk about neighboring environment to what Dr. Chris mentioned before about mangroves, especially how we utilize remote sensing for mangrove research. And in this case, I'm going to talk more about how to map mangrove species using remote sensing data. Next, please. The outline of my presentation will be the first, I'm going to talk about the background, why is this topic important for us, and also to deliver in this occasion. And the second part is about the approaches that we have been trying and error for a couple of years. So that's back in starting in 2017, and then up to recent research that we've done in our research group. And also, I'd like to present later on some of the example of the research from my students. And so that's covering our approach on mapping mangrove species based on the spectral reflectance, and then the object-based image analysis and the vegetative phenological pattern analysis. And then we come up with the conclusion. So to start this presentation, next please. If we talk about the global mangrove extents, we can see that there are 3 mangrove richest countries around the globe, which is summarized by Spalding in 2010, Giri et al. In 2011, and the last one is Banting et al. In 2022. So those countries are Indonesia, Brazil, and Australia. And if we see across the column of that table, there are differences in numbers because in numbers or in the percentage because of the difference in the way they map or the way they calculate the extent of mangroves. Spalding, for example, they use any sources available at the time, even statistical calculation or maybe a report from many countries that they calculated. Giri, for example, used mostly Landsat data to map global mangrove area or mangrove extents and come up with that amount of figure. And then Banting recently used a mangrove specific algorithm to see where is the mangrove area versus the non-mangrove area. And overall, we can see that Indonesia at this point has the largest mangrove countries around the globe. on the right side, we can also see that from Banting reported in 2011 that there are some mangrove richest countries which is reside along the equator and also expanded about 30 degrees north and south, including Indonesia and some in Southern America, including Australia as well, and also some in Brazil. And at the moment we are lucky because Indonesian government, we have Indonesian national mangrove maps in year in 2021. That's the most updated map. And from that map we can calculate that the area of mangrove is about 33,000 kilometers square, which is roughly more or less equal to what calculated by Spalding and Kiri and also Banting. So in terms of the extent, Indonesia is the most largest mangrove countries. Next, please. And then if we talk about the second part of the mangrove, about the biodiversity, there are 75 mangrove species recorded throughout the world, and 63 species is in the West Pacific, or IWP, and 12 is in Atlantic, East Pacific, or AEP, sorry. And Indonesia is estimated to have approximately 43 true mangroves species according to Kusmana, and that 75 true mangrove species according to Spalding, and about 50%, 57% of the world mangrove species. And you can see from the map from Spalding in 2010 that the dark red is where the mangrove species mostly resides. That's around Indonesia, around the head of Papua and those areas. And as mentioned by Dr. Chris previously, that this mangrove distribution pattern is also closely mirrored by the corals, reef fish, and also seagrass environment. So it makes that Indonesia and around of that area is the richest biodiversity location for mangrove, seagrass, and also coral reef. Next, please. So those two reasons bring us into our curiosity on how to use remote sensing data to identify or to discriminate one species of mangrove to the other. And if we can see that pie graph on the left side, Indonesia comprises of 90% of mangrove area throughout the world, but it has 57% of the species of the world. So that's come up into a question how to identify and map mangrove species from remote sensing image. For example, in the image on the right, I was playing around with the red, green, and blue composition of the mangrove area that was in Bedul, Banyuwangi, in East Java. That's from the World View 3 image, and we can see that there are, so much color that come out from that image, and we, as a scientist, also curious what are they, and is that different colors? Is that different colors show us different species, for example, or different group of mangrove composition, for example? And then we, that's why we need to, we need to really push remote sensing data to map that mangrove species. Next, please. So the first approach that we are going to present is about the spectral reflectance approach base that we use. So in theory, each mangrove species has its own spectral fingerprint that distinguishes from one species to the others. So there are a couple of literature this statement, including Hirano, Faipasa, and Quenser. And what this, the up and down, or the reflectance, the signature of the spectral reflectance for each species is served as a spectral fingerprint that we try to use that each species for mapping each species of mangroves. And if you see that up and down of the spectral curve, it is caused by the different ability of each mangrove species in absorbing and reflecting the electromagnetic energy, especially in the near infrared. We can see that there are the high, reflectance, and also in the short wave infrared, where have most noticeable spectral intensity distance. So, based on this spectral signature, we can assume that we can use that as a clue for identifying one species of mangrove to the other. For example, in this case, that is the Avicennia marina and Rhizophora conjugata. So they have a different spatial signature. And all of those literature that we cite on here are based on laboratory work, where the researcher took the sample from the field and then bring it to the laboratory and measure it in the laboratory. And what we are going to do is a different approach. Like we go into the field, we bring our equipment and we measure the spectral reflectance of each species in situ in the field. Next, please. So this is the first example of our work in using the spectral reflectance base for mapping mangrove species. So basically, this work was in 2017. We collected spectral reflectance of mangrove species from the field that we come across in the field, and then we take a sample. And then we develop the mangrove species spectral library, and then based on that spectral library, we try to map the distribution of the targeted species. The location is in Karimun Jawa Island, Central Java. This area is very interesting because in a small island, so this one is located in the southern part of Semarang in Central Java or Jepara. Within this small location, there are three or more ecosystem. There is mangroves, there is seagrass, and also coral reef, and also the the upper land vegetation. So this area we often visit it regularly with also Pak Prama and team. And also this is the place where, if you remember the picture of Dr. Rosma show us about the remote sensing training that was held in this island. And the way we do it is we use oceanoptic spectrometer, which has a range from 325 nanometers to 1024 nanometers. We bring it to the field. It's a kind of a small spectrometer which can be portable. We can carry it around the field, and we measure the leaf of targeted species a close range within probably 2 centimeters to 5 centimeters away from the leaf, and then we did repeated readings like 10 or 15 times, and then we average the readings, and that's our spectral library. Next. From that fieldwork, we collected 14 mangrove species, spectral reflectance, and yes, because of the high spectral resolution of the spectrometers, that's different to the spectral resolution of the image. So the challenge is how to incorporate the ultra spectral data for the spectrometer into multispectral data. In this case, we use the worldview to image, which has only 8 bands. So we try to convert from 2050 bands to 8 bands only. So we do spectral resampling technique to do this. So you can see the difference between the left spectral signature and the right one. The left is the original from the spectrometers, and the right is the resampled one according to the spectral reflectance of the worldview image. And then we use the right one to serve as a reference for mapping for the targeted mangrove species features later on. And next, please. We use the spectral angle mapper in this research to identify and classify the targeted 14 mangrove species. Basically, SAM is a classification based on the spectral angle formed by a pixel, so a spectral reference value on a feature space. So the smaller degree or angle formed by between targeted spaces, a targeted object to the reference, that means that sample is belong to that reference. And there is also limitation of about this SAM technique, because it's only see the direction of the angle, but not the length of the angle. So the intensity of the light is not something that is considered in this algorithm. And on the right side is the result of our trial in mapping mangrove species from 14 different samples. And from the error matrix, we found that 47 samples correctly mapped from overall 76 validation samples, and that makes this map is 62% accurate overall accuracy. Yeah. And which is not so good, but at least we can show that using this type of method or step, we can see the distribution of the mangrove species map, and this has been published in the proceeding of SPI. Next, please. The second example is done by our student Rahman Dana in 2022. The first example is we tried use the sample from the field to map mangrove species, but in this case we tried to use the dendrogram, which is commonly used by ecologists or biologists, and try to create clusters of similar objects, and then try to map that clusters into several levels. And first, from that spectral resampled object, we use word linkage to classify mangrove species based on the distance between the closest clusters of spectral reflectance patterns, and the input is from the resampled spectral reflectance itself. So in this case, instead of 14, our student Rahman Dana collected 24 different species in the same location in Karimun Jawa Island, and it results in four different levels of details of groupings of the species, level 1 to 3, and the last one is the individual species level. And we use this dendrogram analysis for pixel-based classification. Next. We applied that dendrogram to world view image using the spectral angle mapper, spectral information divergence, SID, and also the spectral feature fitting or SF algorithm. We try to compare those three different algorithms in this mapping. And the table on the left is the leveling or the cluster analysis result from level 1, 2, 3 to 4, and that consists of several close or neighboring species of mangroves. And the right side is the result, which is we can see that there are huge difference between one level to the other, and also one algorithm to the other, which is quite interesting for us. Next, please. And from that approach, with the help of dendrogram analysis, we find that accuracy is very low at the individual species level, which is only 5.08%, and that's obtained by the SFF algorithm. And for the level 1, the highest is from the SID, the second level also the SID, and the third level also from the SID algorithm. And that's still low or lower than the first example of our effort to map mangrove species. And some lesson learned here that the pros from the SAM is that it's able to classify pure pixels, but insensitive to factor other than a spectral angle, like I mentioned before. it's only use the direction of the spectrum, but not the length or the intensity of the light coming into the or recorded by the spectrometers. The SEED algorithm, it's able to measure the spectral variability of a single mixed pixel and determine spectral similarity, but it is less effective on mixed pixel targets. And for the SFF, the pros is it can classify area with high diversity. The output is a scale image and a separate or combined RMS image. And the cons is the process took longer time than the SEM and SEED. And we also see that from the accuracy assessment result that the more classes that we incorporated from level 1 to the level 4, the lower the accuracy resulted. Next, please. And those two examples were using the worldview image data, which is multispectral, and the third example is we try to use the second approach to Prisma hyperspectral data, and we wanted to see if the hyperspectral data can produce more accurate data or information in this sense. So we apply a similar approach to Prisma hyperspectral data using SEED algorithm. This one is done by Hasandi, our student. And we use SEED because the previous research shows us that the SEED is the has more accuracy compared to other algorithm. And then we try to compare the performance of original 30 meters Prisma data with 9 meter pan-sharpen data using smoothing filter based intensity modulation. And we can see from the left side of the spectral reflectance here the 2050 reflectance from bands from the spectrometers compared to the 240 bands from the Prisma data. And the right side, we still use the same approach. We use the dendrogram analysis, and it also produces 4 levels of information from level 1 with only 2 classes, level 2 with 4 classes, and also for the level 4 for the individual one. Next, please. And for the accuracy assessment, we compare the original and pan-sharpen data. In this case, we can see that for the level 1, there's only 2 groups. The original data result in 65.7%, and the pan-sharpen result in 74.29%, which is not so much difference. And also in the level 2 and the level 3, there are only subtle difference between the original data and the pan-sharpen data, and exactly the same for the level 4. And the lesson learned from this trial and error with the hyperspectral data is that the use of hyperspectral data, yes, it is increased the accuracy of the dendrogram clustering, and the pan-sharpened image slightly increase the overall accuracy of mangrove species or group mapping. And in this case, we can conclude also that the image pixel size or the spatial resolution plays more important roles in mangrove species mapping than the number of the band or the spectral resolution. Next, please. The next approach that we use is using the object-based image analysis, and it's still with the same assumption that the mangrove or each mangrove species has its own appearance characteristic, but in this case more than the spectral, but more to be that they have different groupings, they have different texture, they have different colors, and etc. And the location is in Selungkup Mangrove Conservation in Malang, East Java. This environment is specifically interesting because it's located in a karst area. You can see the domes with the like circle hills, and the mangroves grows in the river, on the river, or on the valleys between the domes. And we use Worldview 2 image for this case, and basically this study aims to develop clues identifiable from image for mangrove and for mangrove and non-mangrove, and also from mangrove species mapping. We apply a multi-level segmentation and classification approach for this research. Next, please. We use the hierarchical approach in GeoBia, or in object-based image analysis. The first level, we focus on mangrove and non-mangrove discrimination. We apply image segmentation. In this case, we use the scale parameter of 5, and we accommodate more colors than shape, and also the more compactness in this case. And we are lucky because in this case we differentiate mangrove and non-mangrove. We're simply using the NDVI and using the threshold of 0.5. So more than 0.5 is mangrove, and less than 0.5 is more than 0.5 and is mangrove, and less than 0.5 is mangrove. That's right. And we also acknowledge that this threshold is probably only applicable in this area and might not be applicable to other areas. And the mangrove and non-mangrove estimation in this case is result in 90% of accuracy, which is very good in this case. And you can see from the image on the right, the green part is the mangrove areas and others are non-mangrove areas. Next, please. And the second level is really how to identify from that mangrove area what type of species are there. So we classify using the nearest neighbor classification in GeoBia with training areas and also standard and feature space, and we result in that type of image which show you different type of mangrove species, and that according to the accuracy assessment, that's 84% of the overall accuracy, so which is quite promising. Okay, and that's published in the RSISE in 2023. Next, please. The last approach that we use is using the phenological pattern or vegetative phenological pattern for mangrove species mapping, and it was done by the Random Forest and also GEE. And vegetation phenology describes the plant life cycle, and it involves the cyclical biology, but we didn't see that in this research. We focus on the vegetation, what can we see from the image, for example. And we see from the right side, that's the cycle of the NDVI, EVI, and SAFI from time to time. We used to years of observation from December 2018 to December 2020. And what we try to do is to compare that pattern, the temporal signature pattern for the targeted species, because we there is some paper that says that every species has different response to the different seasonal variation. And then next, please. And the derived variable importance shows that wet months from the middle to the end of the rainy season, February, March, May, and June, have the essential role in differentiating between one species to the others, thus increasing the overall accuracy. And if we see the overall accuracy for NDVI is 82, EVI is 72, and SAFI is 81. And the bottom maps is the map derived from the NDVI and shows the species distribution of the at the location. Yeah. Next, please. So, as a conclusion, we can conclude that remote sensing image has a potential for mangrove species mapping. In this case, image pixel size plays more important roles in mangrove species mapping than the band numbers, and the OPR result in higher accuracy than spectral reflectance base in mangrove species mapping, and the mangrove species vegetative phenological pattern could also serve as a clue for species discrimination for remote sensing images. And we also have a future research, or our homework, which is basically to apply and replicate this approach to other locations and assess the consistency of the result, and also to find a way to increase the accuracy of the mapping result, because what we produce is still considered as a medium to low accuracy. I think that's all. Pak Proyo, thanks a lot.
Thank you very much, Pak Kamal, for a very nice presentation. Yeah, the first speaker talked about the coral reef and then move to the land, talk about seagrass, and Pak Kamal just talked about mangrove. Okay, very interesting. Any question or comments, please? Yes, Dr. Blanco.
Thank you very much, Professor Gamal, for that very interesting and excellent research. So my first question is just to clarify about the prisma, because you mentioned that it's around, I think, 200 plus, no? But you mainly use, I think, the visible part of the cube, which is, I think, less than 100 or less, maybe around 80 bands. The total of the two cubes, the Bisneer and the sphere, is, I think, 200 plus, but they have different number of, I think. Yeah. And what sort of processing techniques did you apply to the prisma bands before, say, applying the different methods like SAM, SEED, and SFF?
Okay, thank you. So you were right, because we only use the bands that are available, so that 205 is the total number of bands, and from that total number of them, we only use like 100 something. So not all of them. The one that we see has a high relevance to mangrove species mapping. So thanks for the correction. And for the processing before the SAM, the SEED, and etc., we basically, from my memory, we try to do local correction of the spectral. So basically, we call it like a relative correction. So we try to get some reflectance from the image, and then we connect that to the object that we measured in the ground, on the ground, and try if there are some differences, and we use some simple statistics to, make these two similar. Yeah, so that's what we done.
I think in many papers they mentioned that certain bands will have to be like removed because of inherently noisy, or other papers are also using minimum noise fraction to filter out the noise, something like that. My other question is about the EVI. EVI, NDVI, and SABI. So the least performance came from the EVI. So what are the possible reasons for such, say, 71% versus 80+% for NDVI and the soil adjusted vegetation index?
Yes, that's an interesting question. And yeah, at the moment, I'm not sure. In that case, the NDVI and SAFI has like 80% plus, and the EVA is lower. What I can see from that graph, EVI has distinct pattern that's different from NDVI and also the SAFI. I'm not sure what happened, but that's something that we need to elaborate more. Yeah.
Okay. Thank you very much.
Thank you.
Thank you very much for the questions, Dr. Blanco. More questions? Yes, please.
Yeah, thank you. My name is Wawan from Malang. I think this is golden moment to have a question with Pak Kamal. Two questions, Pak. The first one is based on your slide. I think there is a significant difference between Banting study related to the coverage area of mangrove in Indonesia compared to the official Indonesian mangrove. And which one, on your opinion, is closer to the reality? And the second question is the method to understand the mangrove coverage, species, etc., is it site-specific or can be applied, reused in other area or geographical regions? Thank you.
Thank you for the question. So, is it Banting or the official mangrove the best one? It's hard because they have different way, different method to map mangroves. Banting used the algorithm and more automated one. The official mangrove maps was using the manual interpretation, visual interpretation, and of course there are some differences, and also the image that they use. Banting use mostly Landsat and those kind of like middle scale images, and the official one they use spot data, which is more it has more spatial resolution in there. And if you say which one is the best one or the proper one, I couldn't answer that because the products derive from different image sources, and that's why they have different areas. For example, if you map something with world view with 2 meters, for example, compared to Landsat with 30 meters, compared to Sentinel with 10 meters, it always result in different areas. Different area. And the second question about the nature of the research is we try our approach in a local site-specific mangroves, and that's our homework to try that on the larger area or maybe on different sites, because at the moment I would say that it is a site-specific, but probably we can apply that to other location using the method is the same, the step is the same, but maybe there is something that we need to tweak a little bit from one place to the other. So that's still our homework. Thank you.
Thank you very much. Unfortunately, time is limited, so we can only limit the opportunity to 2 questions, so that time is up for Professor Kamal, and please give big applause for his presentation. Thank you very much, Professor Kamal. And now we have the 3rd speaker. Is he ready?
Yes.
Okay.
Hello.
Hello. Okay. Yeah. Good morning, Dr. Hansan Park. Yeah. Please allow me to read your CV, very short CV. Your education background is from Kyung Hee University and PhD in Geomorphology and GIS in 2008. Yeah? And then your positions now, the first one is the principal researcher in Korea Institute of Ocean Science and Technology from May 2007 until present. And you are also the co-director of the Korea Indonesia MTCRC from November 2018 until now, present. Okay, so you have 30 minutes for making presentation and 15 minutes for discussion. Okay, so time is yours, please.
Yeah, thank you very much for introducing me. Yeah, I'd like to introduce myself. Yeah, already he introduced me. Yeah, my name is Park Hansan. In my country, yeah, I said family name first and then give name. So Park Hansan is my name, full name. And I serve as the director of the Korean University MTCRC. Yeah, before starting my presentation, I would like to express my thanks to our committee member of this symposium, and very happy to have chance to introduce our center and also activity and that. Actually, you can see that the presentation title, my presentation is not for scientific research matter and also survey kind of that. I will just, I hope, share the information about our activity, and also I'm waiting for the collaboration with Indonesia many stakeholders, especially with UGM. You can, feel free to listen my presentation, related with the previous two variable presentation about the scientific matter. So, contents is like this. I have to, I introduce very shortly about the MTCIC, what we are. And then I want to talk about the equipment and also survey activity and ongoing project contents. So there will be no specific conclusion, because the presentation is a kind of introduction. So MTCS is actually, we are into government joint research center. Sometimes when we introduce ourselves, many people are talking about what is project your, what's project of your center. But actually we are not project, we are kind of operation body, between two government. So we will keep continue our operation, during several decades more. For example, Korea government also have a kind of a joint research center with China, so already is 30 years more. So we hope collaborate with many important stakeholders in Indonesia in the several decades of the future. So, and we established 2018, and also we co-work with ITB for Indonesia, and Korea side is Korea Institute of Ocean Science and Technology. And we have three main functions for cooperation platform, joint research, and capacity building. And additionally, we have project implementation and also governmental and community support. So for the cooperation platform, you already know more about this. So we will hold intergovernmental meeting and also meeting with stakeholders, including ministry, institutions, universities, and others. So for the more extend our cooperation, we already have MOU with important stakeholders in Indonesia, especially in universities, IPB, Bogor, and also Hasanuddin University, and Fatimullah University, and Udayan University, and PPS Denkape, and Dipenongan University. And just last July, we signed on MOU with Gadjah Mada University. So that's why I can invite this meaningful symposium, and I'm very, very pleased to introduce MTCIC in front of you. And we will keep continue our cooperation with many important stakeholders. And second one is about the joint research. Actually, our center is a research center, so we want to develop many meaningful joint research topic. And for that, already we conduct about operational oceanography forecasting system and ocean satellite operation, utilization, and also ocean energy, about blue carbon, and smart aquaculture, and marine debris. So previous two presentations are very closely related with the kind of blue carbon survey analysis. So we also want to cooperate with them. Actually, we already have a cooperation with the UGM, especially Department of Geography. And about the capacity building, we support many students in Indonesia for master degree, and also we invite some students to get the doctor degree in Korea, and also for the training course, we many training courses. So with kind of special lectures from Korean lecturers, and also many field training with the actual equipment and actual data processing with, so that will be valuable for many students who want to know about cutting edge technology related with ocean and marine, including earth science. And for introduce ourselves, we need to also let you know that we have our own operated equipment, including survey and training boat. 2020, we have Arabot 1. It is just only 12 meter length boat, but it is very specialized for the coastal area, so easy to access shallow water, and also many equipment can easily adapt, install that boat. And just this month, we have a second boat. It's a little bit more longer and wider, and more powerful. Yeah, so it will be helpful to survey on coastal area and also for the training purpose. And with many equipment, multiple macro sounder, SVP, ADCP, and CTDs, and also hyperspectral radiometry. And with also numerical model server and computers and laptops and that workstation. And last year and this year, we also installed a laboratory for marine chemistry and also blue carbon. So marine chemistry, we have FTIR and the nutrient auto analyzer and also heavy metal analyzer. And for the blue carbon survey research, we have a CN analyzer. So this instrument is very, very important to analyze the seawater pollution in Indonesia, water, and also for the blue carbon survey, we also need to measure the exact carbon sequestration rate and something like. And especially for remote sensing, we also have a fixed wing drone developed by Korea company with Israel. It is very strong for coastal area because the aerodynamic characteristic is strengthened to the side wing. And also this body is very light, and also it can be waterproof. Not full waterproof, but it can. This drone can land it on the sea. So that means that we can operate coastal area more easily and more safely. And also many DJI drones, and also we have a rider to operate by drone. So it will be very helpful to know about the mangrove forest canopy and also characteristics and also coastal area. And the GNSS system, RTK, and we also have USIMO spectrometers. So already previous presentation mentioned about the measure about spectrum radiometric characteristics by species. And, that kind of thing is conducted by this instrument. So we have USIMO and also trials Ramses. So we already conduct several field campaign, and we hope also utilize with UGM and also many stakeholders in Indonesia. So actual survey, sometimes the research, joint research between two countries, kind of a bilateral cooperation, they only facilitate the cooperative research method, but they don't conduct by own field survey, but we have the equipment and also researchers, so we can conduct our own survey by ourselves. So it will be also very helpful to co-work with those many stakeholders. So this is a kind of a case. So first one is using the Keva drone. We survey in Jakarta mangrove park, and we also extract the canopy, and it will be calculated. Using some formula to convert it to carbon amount in the biomass. Of course, it is kind of just a trial. So using this equipment, we can develop more high technologies, analysis methodology, and also need to validate and develop more. And for the ICRG project, also we survey bathymetry and also banting mapping. And also last year we also conduct same area and to know about the under the seas the classification using hyperspectral sensors. this is one case, the comparison with 2020 and 2022. So we can find out that the changes of very precise imagery, and also using hyperspectral sensor, so it can apply to classification. Of course, we should develop more technology and apply, and the kind of geographical object-based image analysis already presented by previous presentation. To use this base data, we can apply many kind of algorithm and also technology to know about banting mapping, to know about the characteristics of seabed and also banting mapping. So this year also we continue. So that means we have 3 data set for this area with not only for remote sensing data, but also in situ survey by CTD. So there will be some parameters such as chlorophyll and the temperature and conductivity. And this is another case in KRN. Actually, this survey is suggested by, requested by Indonesian government to develop the new seaweed aquaculture estate. So they have a 4 candidate area, and which area will be good for the next culture-based area. But when we arrive at this area, we asked to where is the culture-based area and we conduct survey, and we also knows about the exact boundary of culture-based area. And actually, in this map, we can see the red line represent about the low tide line. So that means this area will be exposed by sun when low tide. But they cultivate this area. So the quality of the seaweed is a little bit lower than the other area, kind of this area. The almost cultivated area is out of the boundary of tidal zone. So the productivity is more higher than this area. So that means using the remote sensing data, and that will be helpful to maximize the productivity of the seaweed based on the temporal and spatial characteristics related with the ocean's tide level and also bathymetry kind of that. And next one is what we have a specific project. Actually, to conduct a kind of collaborative activity, we need also budget. So we can link it with the ongoing project. So from the Indonesian government, especially Kemenkomarbas Pak Luhut Minister, he mentioned about the importance of the 2 countries' cooperation and also the successful case and MTCIC. So we can develop the ocean satellite project. It is very exactly related with remote sensing methods. Actually, GeoComSat 2B is placed on the sky of Maluku Utara, and it's a geostationary satellite, so it can capture, it can get the whole of Indonesia's territory's data every day, and we want to utilize together with Indonesia. So the project is started just last year, and it will be continue 5 years. And also will have the capacity building project, entitled with the establishing integrated ocean fishery technology training center and capacity building program. So we will make the center in Ancol, Jakarta, and also we support students, master degree students every year, 40 master degree students, and also invited technical degree students in Korea. And also we developed aquaculture project. So this project also will start just this year. So this kind of activity, MTCIC's activity is very closely related with develop capacity of science and technology related with earth science, especially, of course, marine and ocean. But that is also one part of earth science. And yeah, so I hope I hope we can have a collaborative activity with many stakeholders in Indonesia, and also develop our capacity together with Indonesia and Korea. Yeah, thank you very much. Yeah, for my presentation. Yeah.
Thank you very much, Dr. Hansen Park, for a nice presentation. And now time for discussion. Any question or comments from the audience? Please. Yeah. From Pak Kamal, any question? No, not yet. I have small question, Dr. Hansen Park. In the near future or in the long run, is there any idea to involve more people with broader context, scientific context? I mean, in this project, for example, involving studies related to the socio-economic aspect of the research results. Yes, please.
Yeah, thank you for the question. Yes, that is a very important point for the government. Actually, yeah, to realize the result of research, scientific research to have to apply to real world. I mean, our life. So yeah, maybe you mentioned about the socio-economical matters research with this scientific method is also key point about that. Key point to realize that our effort. So actually we have a plan to develop a kind of MSP, Marine Spatial Planning, for Indonesia. So that should needed kind of scientific data, and also consider about the many things for socio-economic matter. So that kind of topic will be one concrete example to apply socio-economic matters for this field. So summarize for my answer is we can have a collaborate with a kind of MSP method for the socio-economic matters in coastal area, linked with scientific survey and data and analysis.
Okay, thank you. Yeah. More questions or comments, please? Probably opportunity to be involved in the research. No? No questions? Okay, I think time is up. And thank you very much, Dr. Hansen Park. And please give big applause for his nice presentation. Yeah.
Ya, terima kasih banyak.
Terima kasih. Yeah, so this session already completed, and I would like to say thank you for all presenters, Dr. Chris Rosma, Professor Kamal, and also Dr. Hansen Park. And we will have a break after this. Okay, return to the MCs. Yeah, thank you very much.
Thank you so much for Mr. Professor Dr. Projo Danudoro. Before we close this session, I would like to ask Mr. Projo Danudoro to give some little souvenir for our keynote speaker. And some small our gratitude for Mr. Professor Dr. Kamal also from Department of Science, Information, Geographic Information Science Department. Thank you so much. For today, we just finished our plenary session. We will have a break, and we will start our parallel session at 13 p.m. All the participants could have a lunch break on the left side of this auditorium. Thank you so much.